Welcome to the quiet journey, a place where curiosity slows down, where thoughts are allowed to drift without direction, and where the vastness of the universe unfolds gently, without urgency. Wherever you are listening from tonight, there is nothing you need to do. No facts you need to memorize, no destination you need to reach. This is simply time set aside to rest your attention, to let your mind wander outward into something far larger than the concerns of a single day. As the world around you becomes still, imagine the familiar boundaries of Earth slowly fading into the background. The steady pull of gravity beneath your body remains, but your thoughts begin to lift, moving beyond walls, beyond cities, beyond continents, rising quietly into the dark space above the atmosphere. The stars appear not all at once, but gradually, and are scattered across a vast black canvas that stretches in every direction. Tonight, we are not here to rush through the universe. We are here to move slowly, to sit with scale, to spend time with something immense, far from Earth, far beyond the warmth of the sun and the rocky worlds closest to it. There exists a presence so large that it reshaped the solar system long before life ever appeared here. A world whose gravity reaches across millions of kilometers, influencing objects that never come close to touching it. A planet that does not simply orbit the sun, but quietly dominates its surroundings through sheer mass alone. That world is Jupiter. Jupiter is often introduced as the largest planet in our solar system. But that simple description barely scratches the surface of what Jupiter truly is. It is not merely large in size, it is overwhelming in weight, so massive that its influence extends far beyond its visible clouds, so heavy that it bends the paths of moons, redirects wandering comets, and subtly shapes the history of neighboring planets. Yet Jupiter does not feel chaotic. It does not feel aggressive. It feels ancient, stable, patient. When we talk about Jupiter, we are really talking about mass itself, about what happens when nature gathers enough material in one place that gravity becomes the dominant voice. Jupiter is a living demonstration of what gravity can build when given time, space, and vast amounts of matter. As you listen, you may notice that the pace of this journey is unhurried. That is intentional. Jupiter does not need speed to command attention. It has been here for more than 4.5 billion years, yet quietly holding its position in the solar system while everything else evolved around it. It existed before Earth had oceans, before the moon settled into orbit, before the sun had fully stabilized. In the early days of the solar system, when clouds of gas and dust circled a young, turbulent sun, Jupiter formed quickly. Faster than the rocky worlds closer in, its growing mass allowed it to pull in enormous quantities of hydrogen and helium, becoming something very different from the planets that would eventually host solid ground and liquid water. From the beginning, Jupiter was heavy. That weight shaped its destiny, and it shaped the destiny of everything nearby. To understand just how massive Jupiter is, we must first let go of everyday intuition. On Earth, weight feels personal. It presses our feet into the ground, and it makes objects harder to lift. But in space, mass is not about effort. It is about influence, about how strongly an object pulls on the fabric of space around it. Jupiter's pull is immense. Even from great distances, its gravity announces itself. Asteroids drifting too close feel their paths altered. Moons settle into carefully balanced orbits, locked into slow gravitational dances that repeat over and over again across billions of years. Even Earth, far away though it is, feels Jupiter's presence indirectly, through the way the solar system itself is arranged. And yet, despite all this power, Jupiter remains strangely calm. Its surface if it can be called a surface at all, is made entirely of clouds. Bands of pale creams and deep browns wrap around the planet, sliding past one another in endless motion. Great storms rise and fall, some lasting longer than entire human civilizations. But there is no solid ground beneath them, no sharp edges, only layers of gas growing denser as they descend, compressed by the unimaginable weight above. This is what mass does when it becomes extreme. It smooths, it compresses, it transforms. If you could somehow descend into Jupiter's atmosphere, passing slowly through its upper cloud layers, you would feel the pressure increase steadily. There would be no sudden moment, no clear boundary, just a gradual tightening, a reminder that above you lies more mass than any planet in the solar system, except the Sun itself. Jupiter's gravity at its cloud tops is more than twice as strong as Earth's. If you could stand there, which you cannot, your body would feel heavier. Not because you had changed, but because Jupiter demands more from anything that enters its domain. And as you move deeper, the pressure becomes so intense that familiar forms of matter begin to behave in unfamiliar ways. But all of that comes later. For now, allow your imagination to drift outward toward Jupiter's orbit. It lies far beyond the asteroid belt, in a region where sunlight is weaker and temperatures drop dramatically. From Earth, Jupiter appears bright in the night sky, outshining most stars. Ancient civilizations noticed it thousands of years ago, long before telescopes existed. They did not know its true nature, but they sensed its importance. Even without understanding mass or gravity, they could see that Jupiter moved differently, slower, more deliberately, commanding attention without effort. As telescopes improved, Jupiter revealed more of itself. Moons appeared around it, orbiting like a miniature solar system. Storms resolved into swirling patterns. The great red spot emerged as a persistent feature, larger than Earth itself, refusing to fade away. Each discovery pointed to the same conclusion. This was not an ordinary planet. Jupiter's sheer mass sets it apart from everything else that circles the Sun. If all the planets were placed on a scale, Jupiter would outweigh the rest combined. This single fact changes how we understand the solar system. It means that Jupiter is not just one participant among many. It is a dominant force. But dominance does not mean disruption. In many ways, Jupiter brings stability. Its gravity helps clear debris. It shapes the asteroid belt. It captures objects that might otherwise wander inward. Over long stretches of time, Jupiter's mass acts as a stabilizing presence, quietly influencing the rhythm of planetary motion. As you listen, notice how your breathing naturally slows when thinking about such vast timescales. Billions of years have passed with Jupiter holding its place, turning steadily, surrounded by its family of moons. Human history occupies only a tiny fraction of that time. Our concerns flicker briefly against a backdrop of immense duration. This is one of the reasons Jupiter makes such a fitting subject for rest and reflection. It reminds us how small our moments are, without diminishing their meaning. It places the present inside something far larger, far slower, far more patient. Tonight's journey is not about reaching conclusions. It is about sitting with scale, about letting your mind adjust to the idea of weight so great it shapes worlds. As we move forward, we will return again and again to the question at the heart of this exploration. Not just how big Jupiter is, but how heavy, how massive. How much influence can be packed into a single world before it begins to reshape everything around it? But for now, it is enough to imagine Jupiter as it is tonight, turning quietly in the darkness, wrapped in clouds, holding its moons close, a giant that does not need to speak to be felt, away from the familiar warmth of the sun. The inner solar system, with its rocky worlds and tight orbits, begins to feel distant now, like a memory slowly fading at the edge of awareness. Between the Sun and Jupiter lies a wide, open region of space, a place defined not by emptiness, but by distance. Here, when the light of the sun weakens gradually, spreading thin as it travels outward, temperatures drop, motion slows, orbits widen. The rhythm of the solar system changes. Jupiter does not reside close to the sun. It was never meant to. Its position marks a quiet boundary, one that separates two very different neighborhoods of our solar system. On one side are the inner planets, shaped by heat and scarcity. On the other are the outer worlds, built from abundance, cold, and time. Jupiter stands between them, not as a wall, but as a threshold. From the Sun, Jupiter orbits at an average distance of more than 778 million kilometers. Light takes over 40 minutes to travel from the Sun to Jupiter's cloud tops. By the time sunlight arrives there, it is far weaker than what Earth receives, spreading gently across Jupiter's vast atmosphere rather than warming solid ground. This distance is not accidental. It is a consequence of how the solar system formed. In its earliest days, the Sun was surrounded by a swirling disk of gas and dust. Closer to the Sun, intense heat pushed lighter elements away, leaving behind rock and metal. Farther out, where temperatures were lower, lighter gases like hydrogen and helium could remain. This simple difference created two very different kinds of planets. Jupiter formed in this colder region, a place where material was plentiful, a place where mass could grow. As Jupiter gathered material, its gravity strengthened, allowing it to pull in even more gas. This process happened quickly on cosmic timescales. While the inner planets were still assembling themselves piece by piece, the Jupiter was already becoming massive enough to influence its surroundings. Its position allowed it to act as a gravitational organizer. Asteroids that wandered too close felt their paths altered. Dust clouds were shaped and thinned. The early architecture of the solar system began to settle. Between Mars and Jupiter lies the asteroid belt, often imagined as a chaotic field of debris. In reality, it is sparse and quiet, its objects separated by enormous distances. Jupiter's gravity played a role here, preventing the material in this region from ever forming another planet. Instead, it remains a scattered reminder of the solar system's formative years. Jupiter's orbit is wide and steady. It takes nearly 12 Earth years to complete a single journey around the Sun. During that time, Earth will have circled the Sun 12 times. And this slow, deliberate motion adds to Jupiter's sense of permanence. It does not rush. It does not wander. It follows a path shaped by mass and balance. From Earth's perspective, Jupiter appears as a bright, moving point in the night sky. Unlike stars, it changes position from night to night, tracing a slow path along the ecliptic. Ancient observers noticed this movement long before understanding what Jupiter was. They gave it significance, sensing that it belonged to a different category than the fixed stars. Even without telescopes, Jupiter stood out. It was bright, it was slow, it felt important. As astronomy advanced, Jupiter's true role became clearer. It is not simply one planet among many, but the most massive body orbiting the Sun besides the Sun itself. This fact gives Jupiter a unique influence over the entire system. And its gravity subtly affects the orbits of neighboring planets. It shapes the distribution of small bodies. It defines the boundary between inner and outer worlds. Beyond Jupiter lie Saturn, Uranus, and Neptune, each impressive in their own right. But even among these giants, Jupiter stands apart. It is the first and largest of the gas giants, the anchor point around which the outer solar system is arranged. Jupiter's position also defines a region known as the frost line, a distance from the sun beyond which volatile compounds like water, ammonia, and methane can freeze. This line played a crucial role in planet formation. Beyond it, icy material was abundant, allowing planets like Jupiter to grow rapidly and reach immense sizes. Had Jupiter formed closer to the sun, the story of the solar system would have been very different. Had it formed farther away, its influence would have weakened. But Jupiter formed exactly where it needed to. From its orbit, Jupiter commands a vast gravitational domain. Its reach extends millions of kilometers in every direction. Objects entering this region feel Jupiter's presence long before they come anywhere near its clouds. Space itself seems subtly shaped around it, as if acknowledging the giant's weight. This gravitational domain creates stability. Moons orbit in predictable paths. Trojan asteroids share Jupiter's orbit, clustered in calm regions where gravitational forces balance perfectly. These objects have remained there for billions of years, held gently in place by Jupiter's mass. Jupiter does not exist in isolation. It is part of a carefully balanced system. Its position allows it to interact without overwhelming. And as you imagine Jupiter in its orbit, consider how much empty space surrounds it. The solar system is not crowded. Planets are separated by vast distances, and yet their motions are precisely choreographed. Jupiter's role in this choreography is subtle but constant. It does not pull planets inward dramatically. It does not fling them outward violently. Instead, it nudges, it guides, it stabilizes. This is the quiet power of mass. Jupiter's distance from Earth also affects how we experience it. When Jupiter is closest to Earth, it shines brilliantly in the night sky, dominating the darkness. When it is farther away, it dims slightly but never disappears. Its presence is steady, predictable, reassuring. For centuries, Jupiter has served as a marker of time. Its slow movement helped early astronomers refine their understanding of planetary motion. Its moons became proof that not everything revolves around Earth, reshaping humanity's view of the universe. But beyond its historical importance, Jupiter's place in the solar system tells a deeper story. It shows how position and mass work together, how being in the right place at the right time can change everything. As you continue listening, let this idea settle gently. Jupiter is not just massive because it is large. It is massive because it formed where conditions allowed mass to accumulate, and because that mass has been shaping space ever since. In the vast darkness between the sun and the stars, Jupiter holds its orbit with quiet certainty, a giant positioned not by chance, but by the slow, patient processes of cosmic formation. And there is comfort in this stability, in knowing that for billions of years, Jupiter has followed the same path, turning slowly, holding its place, maintaining balance in a system far larger than ourselves. Numbers alone tend to rush past the mind, especially when they grow large. Millions blur into billions. Kilometers lose meaning. So instead of beginning with measurements, it helps to start with something familiar, something small enough to hold in the mind without effort. Earth. Earth is the world we know by instinct. Its size feels natural to us because it defines our everyday experience. The horizon curves gently away. Gravity feels constant. Distances make sense because our lives unfold within them. When we speak about Jupiter's size, Earth becomes our reference point, our anchor for understanding something far larger. Now imagine Earth floating in space, isolated and complete. A blue sphere suspended in darkness. Clouds swirl across its surface. Continents rotate in and out of sunlight. From a distance, Earth feels whole, self-contained, and substantial. And yet, when placed beside Jupiter, Earth begins to change in scale. Jupiter's diameter is more than 11 times wider than Earth's. This means that if you were to draw a straight line across Jupiter's middle, you could place 11 Earths side by side across that line with space to spare. But even this comparison does not fully capture the difference, because diameter is only one dimension. Volume tells a deeper story. Jupiter is so large that more than 1,000 Earths could fit inside it. Imagine Earth not as a planet, but as a marble. Now imagine a sphere large enough to contain 1,000 of those marbles. That sphere would be Jupiter. This difference in volume is difficult to visualize all at once, so it helps to approach it slowly. Picture placing Earth gently into Jupiter's atmosphere. There would be no collision with solid ground. Earth would simply disappear into the clouds, swallowed by layers of gas that extend tens of thousands of kilometers deep. There would be no edge, no sudden boundary, just more space. From Earth's surface, our planet feels vast. Oceans stretch beyond sight. Continents take days to cross by air. But Jupiter redefines what vast means. Its atmosphere alone is wider than Earth itself. Storm systems on Jupiter can grow larger than entire planets, persisting not for days or weeks, but for centuries. The Great Red Spot, a single storm system, has existed longer than human civilization. At times in history, it has been large enough to engulf Earth entirely. And yet, within the context of Jupiter's immense body, it is just one feature among many. This is the scale Jupiter operates on. When spacecraft approach Jupiter, the planet fills their view long before they arrive. It does not appear suddenly. It grows steadily in size, dominating more and more of the sky, until there is nothing else to look at. Even from millions of kilometers away, Jupiter feels close, simply because it is so large. Earth, by contrast, remains delicate in appearance. Thin, compact, a small world wrapped tightly around a solid core. Jupiter has no such compactness. Its mass spreads outward, forming a vast, layered sphere that transitions gradually from gas to liquid and, deep inside, to forms of matter that behave unlike anything on Earth. When we compare sizes, it is important to remember that Jupiter is not made larger simply because it is empty or hollow. Its enormous size comes from the sheer amount of material it contains. Hydrogen and helium, the most abundant elements in the universe, gathered here in extraordinary quantities. Despite being made mostly of light gases, Jupiter's total mass is immense. Size and mass are related, but not identical. Jupiter's large size allows it to hold onto its gases, while its mass ensures those gases are tightly bound by gravity. From a distance, Jupiter's atmosphere looks smooth and flowing, like thick paint stirred slowly around a sphere. Bands of color wrap endlessly around the planet, revealing rotation and depth. And these bands alone span distances greater than Earth's diameter. If Earth were placed on Jupiter's surface, assuming such a surface existed, it would appear as a small object resting against a backdrop of endless cloud layers. Its mountains would be insignificant, its atmosphere thin by comparison, its entire structure compact and fragile. Jupiter does not diminish Earth's importance, but it places it in context. The solar system is not built around Earth-sized worlds, it is built around mass, and Jupiter holds most of that mass among the planets. This comparison also reveals something subtle. Jupiter's size does not scale endlessly with mass. Despite containing more than twice the mass of all other planets combined, Jupiter is not twice their size combined. This is because as objects grow more massive, gravity compresses their material more tightly. In Jupiter's case, Adding more mass does not dramatically increase its size. Instead, it increases pressure. The planet becomes denser, heavier, more compact internally, even as its visible size remains relatively stable. This means Jupiter represents a kind of balance point. It is massive enough to dominate its surroundings, but not massive enough to ignite like a star. It sits just below the threshold where nuclear fusion would begin, where gravity would compress hydrogen so tightly that it would start to glow. In another universe, or under slightly different conditions, Jupiter might have become something else entirely. But here, it remains a planet, a giant one. As you continue to imagine Earth beside Jupiter, notice how your sense of scale begins to adjust. Earth no longer feels small in a discouraging way. It feels specific, defined. One world among many, each shaped by different conditions and histories. Jupiter's size reminds us that the universe builds on a scale far beyond daily experience. But it also reminds us that size alone does not determine significance. Earth, though small, hosts life. Jupiter, though immense, remains a world of storms and gas. Beautiful but inhospitable by our standards. Both belong. As this chapter comes to a close, let the image of Jupiter and Earth remain gently in your mind. One vast and diffuse, the other compact and familiar. Two worlds sharing the same star, connected by gravity and time. Understanding Jupiter's mass, approx 2,500 words. Size is what we notice first. Mass is what truly matters. As we move deeper into understanding Jupiter, it becomes important to separate these two ideas. A planet can appear large and yet be relatively light. Another can be smaller but incredibly dense. Mass is not about how much space something takes up. It is about how much matter it contains and how strongly that matter shapes the space around it. Jupiter's defining characteristic is not simply that it is wide or visually impressive. It is that it contains an extraordinary amount of material gathered into a single body. More material than all the other planets combined. More gravitational influence than anything in the solar system except the Sun itself. To grasp this, it helps to imagine a scale, not a physical one, but a conceptual balance. On one side, place Mercury, Venus, Earth, Mars, Saturn, Uranus, and Neptune together, all of their rock, ice, metal, and gas combined. Like on the other side, place Jupiter alone. The scale tips decisively in Jupiter's favor. This single planet outweighs them all. This is not an exaggeration or a poetic statement. It is a measurable fact of the solar system. Jupiter contains about 70% of all planetary mass orbiting the Sun. That concentration of mass has consequences that ripple outward through space, shaping orbits, influencing formation, and determining the long-term stability of the system. Mass expresses itself through gravity. The more mass an object has, the more strongly it pulls on everything around it. Jupiter's gravity is not confined to its immediate surroundings. It extends far into space, forming a region of influence so vast that objects entering it feel Jupiter's presence long before they approach the planet itself. This region is sometimes described as Jupiter's gravitational sphere of influence, and it spans tens of millions of kilometers. Within this invisible domain, Jupiter becomes the dominant force, guiding the motion of moons, asteroids, and passing bodies with quiet authority. But mass does more than pull. It compresses. Inside Jupiter, gravity presses inward from all directions. Gas that would remain light and diffuse on smaller planets becomes dense under Jupiter's weight. Hydrogen, the simplest and lightest element in the universe, behaves very differently when stacked in such enormous quantities. Layer by layer, Jupiter's mass presses downward. The deeper one goes, the stronger the pressure becomes. What begins as gas transitions gradually into liquid and then into exotic states of matter that challenge everyday intuition. Not all of this is driven by mass alone, by gravity insisting that matter gather closer and closer together. Despite being made mostly of hydrogen and helium, Jupiter is not light. Its immense mass comes from the sheer quantity of these elements it holds. There is so much of them that even their lightness cannot prevent Jupiter from becoming extraordinarily heavy. This highlights an important idea. Mass is cumulative. A single molecule of hydrogen weighs almost nothing, but trillions upon trillions of them gathered together becomes something powerful enough to shape an entire planetary system. Jupiter is proof that gravity rewards abundance. It is also important to understand that Jupiter's mass reached a limit. As more material accumulated, gravity compressed the planet further, preventing it from expanding endlessly. This is why Jupiter is not vastly larger than Saturn, despite being significantly more massive. Additional mass increases pressure more than size. This compression makes Jupiter dense in ways that are not obvious from its appearance. From afar, it looks soft, fluid, almost delicate. But beneath that appearance lies an interior under pressures millions of times greater than those found at Earth's surface. Jupiter's mass also influences time. Objects orbiting Jupiter move faster than they would around a lighter planet. Spacecraft approaching Jupiter gain speed rapidly, pulled inward by its gravity. This same effect has been used by humans to slingshot probes deeper into the solar system, borrowing a small amount of Jupiter's momentum. Even light is affected, bent slightly as it passes near Jupiter's immense gravitational field. And this effect is subtle, but measurable, and it reinforces the idea that mass shapes not just objects, but space itself. Jupiter's mass is also responsible for its role as a protector. Asteroids and comets that wander into the inner solar system often encounter Jupiter first. Some are captured, others are deflected. A few are sent on entirely new paths. Over billions of years, this process has influenced how often Earth experiences large impacts. This protective effect is not absolute or intentional. It is simply the natural consequence of Jupiter's mass interacting with smaller bodies. Gravity does not choose. It responds. When we speak about Jupiter's mass, we are really speaking about balance. Too little mass, and Jupiter would not have become a gas giant. Too much, and it might have ignited into a small star. Jupiter exists in a narrow range, heavy enough to dominate, but light enough to remain a planet. This balance defines Jupiter's identity. It also defines its future. Jupiter's mass is stable. It is not losing material at a significant rate. It is not gaining much either. For billions of years, it has remained essentially the same giant it became early in the solar system's history. This stability is calming to consider. While smaller worlds change more dramatically, Jupiter persists. Its storms shift and evolve, but the planet itself remains, anchored by its mass. As you rest with this idea, allow your thoughts to settle around the concept of weight on a cosmic scale. A single world holding so much matter that it reshapes space around it. A planet whose influence is felt across millions of kilometers without ever making a sound. The invisible expression of mass reveals itself through gravity. It is the language mass uses to speak to the universe. Jupiter's gravity does not announce itself with sound or light. It is not something that can be seen directly. And yet, it is the most constant and far-reaching expression of Jupiter's presence. Everything near Jupiter, whether it touches the planet or not, feels this invisible pull. Gravity is not a force that turns on and off. It does not surge suddenly or fade without warning. It is always there, shaping motion quietly and continuously. Around Jupiter, gravity is strong enough to dominate an enormous region of space, extending far beyond the planet's cloud tops. As objects drift closer to Jupiter, their paths begin to curve. Space itself seems to guide them inward. Moons settle into stable orbits. Asteroids slow, accelerate, or change direction. Even passing comets feel Jupiter's influence long before they come anywhere near its atmosphere. This gravitational reach is vast. Jupiter's sphere of influence stretches millions of kilometers outward, forming a region where its gravity outweighs the pull of the Sun for nearby objects. Within this domain, Jupiter becomes the central reference point, quietly commanding motion without resistance. The strength of Jupiter's gravity is a direct result of its mass. More mass means stronger curvature of space. The fabric of the solar system bends gently around Jupiter, guiding objects along paths that repeat with remarkable consistency over billions of years. At Jupiter's cloud tops, gravity is more than twice as strong as Earth's. If a body could remain there, it would feel heavier, pressed downward by a pull that never relaxes. But this gravity does not become overwhelming all at once. Like everything about Jupiter, it increases gradually with depth and proximity. The deeper one moves into Jupiter's gravitational field, the stronger the pull becomes. Spacecraft approaching the planet gain speed rapidly, drawn inward by Jupiter's mass. This acceleration is predictable and smooth, allowing engineers to use Jupiter as a gravitational tool, bending trajectories and saving fuel. This technique, known as gravitational assist, relies entirely on Jupiter's immense mass. By carefully passing near the planet, spacecraft borrow a small amount of Jupiter's orbital momentum, altering their own paths. It is a subtle exchange, one that barely affects Jupiter, but dramatically changes the journey of a much smaller object. The gravity also binds Jupiter's many moons. Each one follows a precise path, shaped by Jupiter's pull and influenced by the presence of neighboring moons. These orbits are not random. They are locked into rhythms, resonances, and patterns that repeat endlessly. Some moons are caught in gravitational dances, where their orbits influence one another in predictable ways. These interactions generate heat, tension, and motion, transforming otherwise cold worlds into active environments. All of this traces back to Jupiter's mass, expressing itself through gravity. Jupiter's gravity is strong enough to hold on to light gases that smaller planets cannot. Hydrogen and helium, which escape easily from Earth's gravity, remain bound to Jupiter, forming its vast atmosphere. Without this gravitational strength, Jupiter would look very different. This ability to retain gas is one reason Jupiter grew so large in the first place. As it accumulated mass, its gravity strengthened, allowing it to pull in even more material. This positive feedback loop continued until Jupiter reached its current state, a massive body wrapped in layers of compressed gas. Gravity also shapes time around Jupiter. Clocks near massive objects run slightly slower than those farther away. This effect, predicted by relativity, is subtle near Jupiter, but real. Time itself bends gently in the presence of mass, reminding us that gravity influences more than motion. Jupiter's gravity extends beyond its moons. It affects the asteroid belt, sculpting gaps and clusters through resonance. Objects that orbit the Sun at certain distances experience repeated gravitational nudges from Jupiter, gradually shifting their paths over long periods. These effects are slow and patient. They do not require sudden impacts or dramatic collisions. Gravity works quietly, shaping systems over millions and billions of years. Jupiter's mass gives it the authority to perform this work on a grand scale. When comets approach the inner solar system, Jupiter often acts as the first major obstacle. Some comets are captured into new orbits, Others are flung outward or redirected. A few collide with Jupiter itself, releasing immense energy high in its atmosphere. These events are reminders of Jupiter's gravitational dominance. Smaller bodies are subject to its pull, their fates altered by a planet they may never touch. Despite this power, Jupiter's gravity is not destructive by default. It is structured, balanced, predictable. It creates order as often as it creates chaos, depending on circumstances and distance. This balance is what allows the solar system to remain stable. Jupiter's mass could have disrupted planetary orbits entirely if conditions were different. Instead, it occupies a position and follows a path that supports long-term harmony. As you reflect on Jupiter's gravity, notice how the idea of invisible influence mirrors many quiet forces in life. Things that shape outcomes without announcing themselves. Things that work slowly, consistently, and without drama. Jupiter's gravity does not demand attention. It simply continues, moment by moment, holding moons in place, guiding debris, and shaping the architecture of the solar system. The atmosphere. Under enormous pressure, Jupiter's atmosphere is not a thin veil resting lightly on a solid surface. And it is a deep, layered world of its own, shaped entirely by mass and gravity. From a distance, Jupiter appears wrapped in soft bands of color, as if painted gently across a giant sphere. Creams, browns, subtle reds, and pale whites drift endlessly around the planet. But this appearance can be misleading. What looks smooth and distant is, in reality, an atmosphere so vast that it dwarfs entire planets. There is no clear line where Jupiter's atmosphere ends and the planet itself begins. Instead, there is a gradual transition. As one moves downward, gas becomes thicker, pressure increases, gravity presses more insistently, the atmosphere deepens until it becomes something else entirely. This is what enormous mass does. It refuses sharp boundaries. Jupiter's gravity pulls its atmosphere inward from all directions. Every layer is held tightly in place by the weight of the layers above it. The higher clouds float in relatively lower pressure, moving freely and quickly. But below them, the atmosphere grows heavier, denser, and more compressed. Hydrogen and helium dominate Jupiter's atmosphere, the same elements that make up most of the Sun. On Earth, hydrogen rises and escapes easily into space. But Jupiter's gravity is strong enough to prevent that escape. Even the lightest gases remain bound, piling up layer upon layer over billions of years. As you imagine descending into Jupiter's atmosphere, there is no sudden sensation of falling. Instead, there is a steady, gentle increase in pressure. The gas around you thickens almost imperceptibly at first. Motion becomes slower. Resistance grows. Cloud layers pass one by one. Each layer marks a different temperature, a different pressure, a different chemical composition. Ammonia clouds give way to ammonium hydrosulfide. Deeper still, water clouds form, far below anything seen on Earth. These clouds are not wispy or light. They are massive structures, driven by convection and heat rising from Jupiter's interior. Pressure increases rapidly with depth. What begins as something Earth-like becomes utterly alien. At depths where pressure on Earth would crush steel, Jupiter's atmosphere continues uninterrupted. There is still no surface, only more gas, more density, more weight. This crushing pressure is a direct consequence of Jupiter's mass. Gravity pulls everything inward, compressing the atmosphere tighter and tighter. The deeper you go, the more the gas behaves like a liquid. Molecules crowd together and are forced into proximity by relentless weight. Temperature rises as well. Jupiter emits more heat than it receives from the Sun. This internal heat comes from slow gravitational contraction, a process driven by mass itself. As the planet continues to settle and compress, it releases energy, warming its depths. This heat fuels motion. Warm material rises, cooler material sinks. The atmosphere never rests. Powerful jet streams circle the planet, driven by the balance between gravity, rotation, and heat. These winds reach speeds far greater than anything found on Earth. Yet they move with a kind of steady persistence rather than sudden violence. Storms form and dissolve. Some grow immense and long-lived. Others fade quietly back into the background. All of them are shaped by pressure gradients created by Jupiter's mass. Unlike Earth, where storms are limited by solid ground and ocean surfaces, Jupiter's storms have room to grow vertically. They extend deep up into the atmosphere, tapping into layers of heat and pressure far below the visible clouds. This vertical depth is essential. Jupiter's mass ensures that pressure increases smoothly over enormous distances, allowing atmospheric structures to stack and interact in complex ways. Storms are not shallow events here. They are deep expressions of planetary weight. As pressure continues to increase, familiar distinctions disappear. Gas becomes fluid-like. Fluid becomes something denser still. Eventually, the atmosphere transitions into a vast ocean of hydrogen, compressed beyond recognition. But even here, there is no surface, no place to stand, only increasing resistance. Jupiter's atmosphere does not end because Jupiter itself does not end in the way rocky planets do. It is a gradient, not a boundary. A continuous transformation driven entirely by mass and gravity. This environment would be utterly hostile to any familiar form of life. Pressure alone would destroy structures long before temperature became an issue. And yet, the atmosphere remains stable, held in place by Jupiter's immense weight. From afar, this complexity is invisible. Jupiter looks serene, almost gentle. But beneath that calm appearance lies an atmosphere under constant stress, shaped by forces far beyond human experience. As you rest with this idea, notice how pressure operates quietly. It does not shout. It does not explode outward. It presses inward, steadily and relentlessly, shaping everything within its reach. Jupiter's atmosphere is a monument to that pressure. A reminder that mass does not always express itself through dramatic motion. Often, it reveals itself through compression, through layers stacked patiently over time. Storms powered by immense weight. On Jupiter, storms are not brief interruptions. They are long conversations between gravity, heat, and time. Where Earth storms are born, grow, and fade within days or weeks, Jupiter's storms can last for centuries. This difference is not simply a matter of scale. It is a consequence of mass. Jupiter's immense weight creates conditions where motion is sustained rather than exhausted, where energy circulates instead of dissipating quickly. The most famous of these storms is the Great Red Spot, a vast, rotating system of clouds, easily visible from Earth through a telescope. And it has been observed for more than 300 years, and likely existed long before humans ever noticed it. The Great Red Spot is not fixed in place. It drifts slowly around Jupiter's atmosphere, caught between powerful jet streams that move in opposite directions. These streams confine the storm, preventing it from dispersing, allowing it to persist far longer than any storm on Earth ever could. At times in history, the Great Red Spot has been large enough to engulf Earth entirely. Even as it has gradually shrunk in recent decades, it remains immense by any standard. Yet within the context of Jupiter's atmosphere, it is only one structure among many. Jupiter is covered in storms. Some are oval-shaped vortices that spin quietly for years before fading. Others are towering plumes that rise from deep within the atmosphere, releasing energy accumulated over long periods. Lightning flashes illuminate cloud tops far below, revealing the power hidden beneath the planet's serene appearance. These storms are fueled by Jupiter's internal heat. Unlike Earth, which receives most of its atmospheric energy from the Sun, Jupiter generates a significant amount of heat from within. This heat rises slowly, driven upward by convection, meeting cooler layers above and creating motion. Gravity ensures that this motion does not escape into space. Everything is pulled inward, recycled again and again through the atmosphere. Energy circulates rather than dissipates, sustaining storms for extraordinary lengths of time. Rotation plays a role as well. Jupiter spins faster than any other planet in the solar system, completing a rotation in just under 10 hours. And this rapid rotation stretches storms horizontally, organizing them into bands that wrap endlessly around the planet. But rotation alone is not enough. Without mass, rotation would produce chaos. Without gravity, storms would dissipate. Jupiter's weight keeps everything bound. As storms rise, gravity pulls them back down. As gases warm and expand, pressure confines them. This constant interplay creates a dynamic but stable environment where storms can exist without tearing the atmosphere apart. The colors of Jupiter's storms hint at the chemistry involved. Reds, browns, and creams may come from complex molecules formed under pressure, brought up from deeper layers by convection. Sunlight alters these compounds, creating subtle variations across the cloud tops. No single explanation fully accounts for the great red spot's color or longevity. Its persistence is likely due to a combination of factors: Jupiter's mass, its heat, its rotation, and the absence of solid ground to disrupt motion. On Earth, storms weaken when they encounter land. Mountains break up wind patterns. Friction with the surface drains energy. Jupiter offers no such resistance. Its storms move freely, unimpeded by terrain, drawing energy from deep reservoirs below. Some storms merge. Others split apart. A few stabilize and endure. All of this unfolds slowly, on timescales that dwarf human experience. A storm that forms today on Jupiter may still be present long after centuries have passed on Earth. This slow persistence is calming to consider. Motion without urgency, change without haste. Jupiter's storms remind us that activity does not require instability. A system can be dynamic and yet balanced, powerful and yet restrained. Mass provides the framework within which this balance occurs. As you imagine these storms, picture them not as violent events, but as slow rotations of energy. Vast systems turning patiently, driven by forces that have been at work for billions of years. Inside Jupiter, beneath the clouds, beneath Jupiter's restless clouds, lies a world that cannot be seen directly. A region shaped not by light or color, but by pressure, gravity, and immense weight. The visible atmosphere is only the outermost layer of Jupiter. Below it, the planet continues inward for tens of thousands of kilometers, gradually transforming as gravity compresses everything tighter and tighter. Once there is no sudden boundary that marks the beginning of Jupiter's interior. Instead, the change is slow and continuous, a steady descent into increasing density. As one moves downward, the familiar behavior of gases begins to change. Hydrogen and helium, free and flowing near the cloud tops, are forced closer together. Gravity presses inward from every direction, leaving no escape. Molecules crowd into smaller and smaller volumes, responding to a pressure that never relents. Temperature rises as well. Heat from Jupiter's interior flows upward, a quiet reminder that the planet is still slowly contracting under its own mass. This contraction releases energy, warming the depths and fueling motion above. Even after billions of years, Jupiter remains active within. The deeper layers are hidden from direct observation, but scientists have learned about them through careful measurement of Jupiter's gravity and magnetic field. Tiny variations in these fields reveal how mass is distributed inside the planet, offering clues about what lies beneath the clouds. These measurements suggest that Jupiter does not have a sharp, solid core like Earth. Instead, its interior appears to be a gradual blend, a region where dense fluids and compressed gases transition smoothly rather than abruptly. This challenges early assumptions and highlights how different Jupiter is from the rocky worlds closer to the Sun. At great depths, pressure becomes extreme. Hydrogen, the simplest element in the universe, is forced into unfamiliar states. Its electrons move freely, allowing it to conduct electricity like a metal. This transformation does not occur suddenly, and it unfolds gradually as gravity continues its quiet work. This interior is not calm or still. Convection carries heat upward, while gravity pulls material inward. These opposing motions create slow, powerful currents that circulate through Jupiter's depths. Everything moves, but nothing moves quickly. The absence of a solid surface allows this motion to continue uninterrupted. There are no boundaries to halt circulation, no rigid layers to fracture or resist. Jupiter's interior is a vast, flowing system shaped entirely by mass and pressure. Somewhere deep within, there may be a core composed of heavier elements, remnants of the early solar system gathered during Jupiter's formation. If such a core exists, it is likely diffuse, blended into the surrounding material rather than sharply defined. This blending is another consequence of Jupiter's mass. Gravity compresses and mixes material so thoroughly that distinct layers blur together. Over billions of years, the planet has settled into a stable configuration, its interior arranged by weight and pressure rather than sharp divisions. As you imagine this descent, let go of the idea of surfaces and edges. Jupiter's interior is not a place with floors or ceilings. It is a continuum, a gradual journey from light to heavy, from gas to fluid, from motion to compression. This hidden world supports everything above it. The storms, the bands, the lightning, and the winds all draw energy from below. Jupiter's visible beauty is rooted in its unseen depths. The immense mass of the planet ensures that these depths remain hidden. They sealed away beneath layers of atmosphere so thick that no probe can survive the journey indefinitely. What we know comes from indirect observation and careful inference, piecing together a picture of a world shaped by gravity beyond anything Earth can offer. As this chapter comes to rest, allow the image of Jupiter's interior to remain abstract and calm, a place of pressure and flow, of heat and compression, existing far beyond human reach. Metallic hydrogen and extreme pressure. Deep within Jupiter, pressure reaches levels that are difficult to describe in ordinary language. It is pressure created not by sudden force, but by patience. Layer upon layer of material pressing downward for billions of years, guided by gravity that never rests. Hydrogen, the most common element in the universe, behaves simply under normal conditions. On Earth, it exists as a light gas, rising easily and escaping into space. But inside Jupiter, hydrogen is subjected to forces so intense that its familiar properties no longer apply. As gravity pulls inward, hydrogen molecules are squeezed closer together. The space between them shrinks. Electrons that once remained bound to individual atoms begin to move freely. At this point, hydrogen stops behaving like a gas and begins to act like a metal. This state is known as metallic hydrogen. It is not metal in the way iron or copper are metals. It does not shine or harden into solid sheets. Instead, it conducts electricity. It flows. It responds to magnetic forces. Its metallic behavior emerges not from chemistry alone, but from pressure so extreme that matter is forced into new arrangements. The creation of metallic hydrogen inside Jupiter is one of the clearest examples of how mass reshapes reality. No furnace is required, no chemical reaction, only gravity pressing inward with unyielding consistency. The pressures required to produce metallic hydrogen are millions of times greater than atmospheric pressure on Earth. These conditions cannot be sustained naturally anywhere else in the solar system. Only a planet as massive as Jupiter can create and maintain them. Within this vast layer of metallic hydrogen, slow currents flow. The material moves gently, driven by heat from below and constrained by pressure from above. These movements are not violent. They are steady and continuous, unfolding over immense timescales. This flowing metallic hydrogen is believed to be responsible for Jupiter's powerful magnetic field. When this electrically conductive material circulates deep inside the planet, it generates magnetic forces that extend far into space. The strength of this field is unmatched among the planets. Again, mass is at the center of the story. Without Jupiter's enormous weight, hydrogen would never reach this state. The planet's gravity compresses matter beyond its normal limits, creating conditions that exist nowhere else nearby. Metallic hydrogen also influences how Jupiter evolves over time. The release of heat from slow gravitational contraction continues to warm the interior, sustaining convection and motion. Jupiter is not cooling rapidly. Its mass allows it to retain energy, releasing it slowly and steadily. This slow release of energy contributes to the planet's longevity. Storms persist. Circulation continues. The system remains active, yet stable. From the outside, Jupiter's clouds appear soft and distant. Beneath them lies an interior defined by density and force. Metallic hydrogen serves as a reminder that even the simplest elements can become extraordinary under sufficient pressure. As you reflect on this hidden layer, consider how unfamiliar states of matter can exist quietly, unseen, sustained by conditions far beyond everyday experience. Jupiter does not need to display these extremes openly. They exist beneath the surface, shaping everything above. Jupiter's enormous magnetic field. Jupiter's magnetic field is not something that can be seen directly. It has no color, no texture, no visible edge. And yet, it is one of the largest structures in the entire solar system. This invisible field is born deep within Jupiter, or in the region where metallic hydrogen flows slowly under extreme pressure. As this electrically conductive material moves, it generates magnetic forces, much like a vast planetary engine turning endlessly in the darkness. Gravity provides the pressure. Heat provides the motion. Together, they sustain a magnetic presence that reaches far beyond the planet itself. Jupiter's magnetic field is stronger than any other planetary field we know. Near the planet, it is more than 20,000 times stronger than Earth's magnetic field. This strength is not evenly distributed. It rises and falls with depth and distance, shaped by the internal structure of the planet and the steady circulation of metallic hydrogen below. Surrounding Jupiter is a region called the magnetosphere. This is the space where Jupiter's magnetic influence dominates over the solar wind. The constant stream of charged particles flowing outward from the Sun. Jupiter's magnetosphere is enormous. If it were visible from Earth, it would appear larger than the full moon in the night sky. The magnetosphere stretches millions of kilometers into space, forming a vast bubble that encloses Jupiter and many of its moons. On the side facing the Sun, this bubble is compressed by the solar wind. On the opposite side, it trails far behind the planet, forming a long magnetic tail that extends beyond the orbit of Saturn. Within this magnetic environment, charged particles are trapped and guided along invisible lines of force. These particles spiral, accelerate, and collide, creating intense radiation belts around the planet. And these belts are far more powerful than Earth's Van Allen belts, posing serious challenges to spacecraft that venture too close. Despite its intensity, Jupiter's magnetic field is structured and stable. It rotates with the planet, sweeping charged particles around in vast arcs. This rotation transfers energy to the surrounding space, influencing the behavior of Jupiter's moons and the plasma that fills the magnetosphere. One moon in particular, Io, plays a special role in this system. Io's volcanic activity releases enormous amounts of material into space. As Io orbits Jupiter, this material becomes ionized and captured by Jupiter's magnetic field, forming a glowing ring of plasma around the planet. This interaction adds energy to the magnetosphere, linking the moon directly to Jupiter's internal processes. Jupiter's magnetic field also creates auroras, similar to the northern and southern lights on Earth, but far more powerful. These auroras appear near Jupiter's poles, glowing constantly as charged particles collide with the planet's upper atmosphere. Unlike Earth's auroras, which are intermittent, Jupiter's auroras never truly stop. This continuous activity is another expression of Jupiter's mass. The energy driving the magnetic field comes from deep within the planet, sustained by pressure and motion that do not fade quickly. Jupiter does not rely on external sources alone. Its interior remains active, feeding the magnetic engine over immense spans of time. The magnetic field also acts as a shield, deflecting some of the solar wind and protecting the planet's atmosphere from erosion. While Jupiter's atmosphere is far too massive to be stripped easily, this magnetic protection adds another layer of stability to an already resilient world. As spacecraft pass through Jupiter's magnetosphere, instruments detect intense radiation, fluctuating fields, and energetic particles moving at extraordinary speeds. These measurements offer indirect glimpses into the processes unfolding deep inside the planet. Processes driven by mass and pressure rather than surface features. Jupiter's magnetic field reminds us that not all power is visible. Some of the most influential structures in the universe exist quietly, shaping environments without ever appearing in photographs. They are felt through motion, detected through instruments, and inferred through their effects. As this chapter settles, allow the image of Jupiter's vast magnetic bubble to form gently in your mind. An invisible sphere of influence, rotating patiently with the planet, enclosing moons and plasma alike. A planet that acts like a solar system. Jupiter does not travel through space alone. It carries an entire system with it. Surrounding the planet is a vast family of moons, rings, and small bodies, all held together by Jupiter's immense gravity. In many ways, Jupiter behaves less like a single planet and more like a miniature solar system, with itself at the center and dozens of worlds moving patiently around it. This comparison is not poetic exaggeration. Jupiter's mass is so great that the balance between it and its moons resembles the relationship between the Sun and the planets. Gravity organizes motion here, while creating stable orbits that have endured for billions of years. More than 90 known moons orbit Jupiter, ranging from tiny fragments only a few kilometers wide to worlds larger than the planet Mercury. Each follows a path shaped by Jupiter's weight, moving in predictable rhythms that repeat endlessly. The four largest moons, Io, Europa, Ganymede, and Callisto, stand out immediately. These Galilean moons are not minor companions. They are worlds in their own right, each shaped profoundly by Jupiter's gravity. Their orbits are carefully spaced, locked into a gravitational pattern that keeps the system stable. As these moons travel around Jupiter, they feel not only its pull, but also each other's. This creates resonances, gentle tugs that repeat at regular intervals. Over time, these repeated interactions generate heat, tension, and motion, transforming otherwise quiet worlds into dynamic environments. Jupiter's gravity keeps these moons bound tightly. Escape is difficult. Once captured into orbit, objects tend to remain, their paths refined over time by gravitational interaction rather than sudden change. This stability allows moons to evolve slowly, shaped by conditions that remain consistent over geological timescales. Beyond the large moons lies a population of smaller ones, irregularly shaped bodies that may be captured asteroids or remnants of earlier collisions. Their orbits are more distant and often tilted, but even they remain within Jupiter's gravitational domain. Rings also encircle Jupiter, faint and delicate compared to Saturn's famous rings. These rings are composed of dust and small particles, likely created by impacts on Jupiter's inner moons. The gravity keeps this material spread thinly around the planet, forming a subtle halo rather than a dense structure. Jupiter's influence extends even farther, capturing swarms of asteroids known as Trojan objects. These bodies share Jupiter's orbit around the Sun, clustered at points where gravitational forces balance perfectly. They have remained in these positions since the early days of the solar system, held gently in place by Jupiter's mass. Within this system, motion feels orderly rather than chaotic. Orbits repeat. Patterns persist. Jupiter's gravity acts as a central organizing principle, maintaining balance across vast distances. This miniature solar system mirrors the larger one in important ways. Just as the Sun's gravity shapes the paths of planets, Jupiter's gravity shapes the paths of its moons. Just as planets influence one another through resonance, Jupiter's moons interact subtly, transferring energy and momentum. The difference lies in scale. Jupiter's system is compact compared to the Sun's, but within it, forces are strong and interactions frequent. Moons move quickly, completing orbits in days rather than years. Yet the system remains remarkably stable. This stability is another expression of Jupiter's mass. Gravity strong enough to dominate does not need to fluctuate wildly. It provides a constant reference point around which everything else arranges itself. As you imagine Jupiter and its moons together, picture a slow, silent dance. Worlds circling worlds. Motion repeating without urgency. A system that has endured since the earliest moments of planetary formation. Gravity turned into fire. Among all of Jupiter's many moons, one stands apart as the most visibly affected by the planet's immense mass. Its surface is restless. Its interior is constantly reshaped. And its activity comes not from sunlight, but from gravity itself. This moon is Io. At first glance, Io does not appear welcoming. Its surface is mottled with yellows, oranges, reds, and dark patches, giving it an almost molten appearance. There are no oceans, no ice caps, no atmosphere thick enough to soften its edges. Instead, Io is a world in constant motion, shaped by forces far beyond its own size. Io's defining feature is volcanic activity. It is the most volcanically active body in the entire solar system. Hundreds of volcanoes dot its surface, some erupting continuously, others awakening after long periods of quiet. Lava flows stretch across the landscape, reshaping the surface again and again. This activity is not powered by radioactive decay or leftover heat from formation alone. It is powered by Jupiter's gravity. Io orbits extremely close to Jupiter, closer than any of the other large moons. At this distance, Jupiter's gravitational pull is intense. But Io does not orbit alone. Europa and Ganymede orbit nearby, and their gravitational influence prevents Io's orbit from becoming perfectly circular. Instead, Io's path around Jupiter is slightly elongated. As Io moves closer to Jupiter, gravity pulls harder. As it moves farther away, the pull weakens. This constant change stretches and compresses the moon over and over again. This process is known as tidal heating. In each orbit, Io is flexed like a soft object being gently but relentlessly squeezed. Its interior warms as friction builds. Rock melts, magma rises, the surface cracks and reshapes. All of this happens without a single spark of fire from the sun. Jupiter's mass makes this possible. Without such a heavy planet nearby, Io would be a quiet, frozen world like many other moons. But under Jupiter's gravitational influence, it becomes something entirely different. The heat generated inside Io escapes through volcanoes that can tower hundreds of kilometers high. Plumes of sulfur and other materials erupt into space, briefly forming thin clouds around the moon before falling back to the surface or drifting away. These eruptions are not rare events. They are ongoing. Some volcanoes have been active for decades, and their lava lakes bubbling steadily, reshaping the surface slowly rather than explosively. Io's landscape changes rapidly on geological timescales. Features form, fade, and are buried beneath new flows. Impact craters are scarce, erased by constant resurfacing. The moon never settles into stillness. And yet, there is a strange calm to this activity. The eruptions are not violent in the way explosions on Earth can be. They are persistent, predictable, driven by a cycle that repeats with every orbit. Io's relationship with Jupiter is intimate and unavoidable. Gravity binds them together, and mass dictates the terms. Io cannot escape Jupiter's pull, and Jupiter cannot stop influencing Io. This interaction extends beyond the moon itself. Material ejected from Io becomes ionized and trapped in Jupiter's magnetic field, forming a glowing ring of plasma around the planet. In this way, Io feeds energy directly into Jupiter's surrounding space environment. Io is a reminder that mass does not only create stability. Under the right conditions, it creates transformation. Gravity can turn motion into heat and heat into change. As you reflect on Io, consider how a small world can be completely reshaped by the presence of a giant nearby. Io's fire is not its own. It is borrowed energy, drawn from Jupiter's immense weight. Oceans shaped by Jupiter's pull. Where Io burns, Europa waits. At first glance, Europa appears calm and distant, wrapped in a smooth shell of pale ice. Its surface reflects sunlight softly, crisscrossed with dark lines and gentle fractures that stretch for hundreds of kilometers. There are no towering mountains here, no deep impact craters. Instead, Europa's exterior feels quiet, almost untouched, as if time moves differently on this frozen world. But beneath that calm surface lies a story shaped by Jupiter's immense mass. Europa orbits farther from Jupiter than Io, but still close enough to feel the giant planet's powerful gravitational pull. Like Io, Europa's orbit is not perfectly circular. As it moves around Jupiter, the planet's gravity stretches and relaxes the moon repeatedly. This constant flexing generates heat deep within Europa's interior. Unlike Io, where this heat melts rock, Europa's heat melts ice. Beneath Europa's frozen crust, scientists believe there exists a vast ocean of liquid water. An ocean that may contain more water than all of Earth's oceans combined. This water remains liquid not because of sunlight, but because of gravity. Jupiter's mass provides the energy, turning motion into warmth beneath the ice. Europa's ice shell is thick, possibly tens of kilometers deep, but it is not rigid. The surface fractures and shifts, suggesting that warmer material from below occasionally rises upward. These movements create the long, dark lines that scar the moon's surface, evidence of an active world hidden from view. There is no solid ground beneath Europa's ice, at least not in the way Earth has continents. Instead, ice floats atop liquid water, moving slowly, reshaping itself over long periods of time. The surface we see is only the outermost layer of a much deeper system. Jupiter's gravity keeps this ocean alive. Without Jupiter's mass, Europa would be a frozen, inert sphere. Sunlight alone is far too weak at this distance to maintain liquid water. But gravity does not fade with distance the way light does. Jupiter's pull reaches Europa steadily, cycle after cycle, orbit after orbit, providing a constant source of internal heat. This makes Europa one of the most intriguing places in the solar system, not because it is dramatic or violent, but because it is stable. An ocean that may have existed for billions of years. An environment shielded from surface radiation. A place where chemistry and time have had room to work quietly. The water beneath Europa's ice is likely in contact with a rocky sea floor. This creates the potential for chemical interactions similar to those found in Earth's deep oceans, where life thrives without sunlight. Hydrothermal activity, driven by internal heat, could provide energy and nutrients in this dark environment. All of this is possible because of Jupiter's mass. The same gravity that tears Io apart fuels Europa gently, providing just enough energy to sustain liquid water without destroying the moon's structure. This balance is delicate and precise, maintained over immense spans of time. Europa's surface reflects this balance. It is young, geologically speaking, constantly renewed by slow movement from below. Craters are few, erased by the shifting ice. The moon appears smooth because it never truly rests, and yet its changes are subtle, quiet, patient. Europa does not erupt, it does not glow, it hides. As you imagine Europa, picture a world wrapped in silence, its surface cold and bright beneath Jupiter's distant light. Beneath that shell, a dark ocean moves slowly, warmed by gravity rather than fire. Jupiter looms large in Europa's sky, a constant presence, its mass felt even when unseen. Every orbit, every flex of Europa's crust is a reminder that this ocean exists because of the giant it circles, Ganymede and Callisto. Stability through mass beyond the restless fire of Io and the hidden ocean of Europa, Jupiter's influence reveals another side of itself, a quieter side, one defined not by constant change, but by endurance. Here, gravity does not tear or melt. Instead, it steadies, stabilizes, and preserves. This is where Ganymede and Callisto reside. Ganymede is the largest moon in the solar system, larger even than the planet Mercury. If it orbited the Sun instead of Jupiter, it would be considered a planet in its own right. And yet, despite its size, Ganymede remains firmly bound to Jupiter, held in orbit by the giant planet's immense mass. From a distance, Ganymede appears muted and calm. Its surface is a mixture of bright and dark regions, ancient terrains alongside younger, grooved landscapes that hint at slow internal movement long ago. Unlike Io's constant eruptions or Europa's shifting ice, Ganymede's changes occur on timescales so long they feel almost imperceptible. Jupiter's gravity plays a central role in this stability. Ganymede orbits farther from Jupiter than Io and Europa, where tidal forces are gentler. The Moon still experiences gravitational flexing, but not enough to generate constant geological upheaval. Instead, the energy provided by Jupiter's pull is subtle, shaping Ganymede slowly over billions of years rather than dramatically. Beneath Ganymede's surface, evidence suggests layers of ice and possibly liquid water exist, stacked like a deep, frozen ocean system. But unlike Europa, this water is trapped between layers of ice, insulated and isolated. The heat required to maintain it comes not from intense tidal stress, but from a combination of internal warmth and Jupiter's distant gravitational influence. Ganymede also possesses its own magnetic field, the only moon in the solar system known to do so. This field interacts with Jupiter's powerful magnetosphere, creating a complex magnetic environment that further shields the moon from radiation. Once again, Jupiter's mass indirectly supports stability, shaping conditions rather than overwhelming them. Callisto lies even farther out. It is the most distant of the 4 large Galilean moons, and in many ways, the most serene. Callisto's surface is ancient, heavily cratered, and largely unchanged for billions of years. It bears the marks of countless impacts from the early solar system, preserved like a geological record frozen in time. Here, Jupiter's gravity is present but restrained. Tidal forces are minimal. Internal heating is weak. Callisto has avoided the dramatic transformations experienced by its neighboring moons. It has remained largely as it formed, quietly orbiting its giant parent. This lack of activity is not a failure. It is a different outcome. Callisto shows us what happens when mass creates order without disruption. Jupiter's gravity keeps Callisto bound, keeps its orbit stable, and protects it from wandering influences, but does not force it into constant change. The result is a moon that preserves history rather than rewriting it. Scientists believe Callisto may also harbor a subsurface ocean, but one that exists deep beneath thick layers of ice, largely isolated from the surface. If such an ocean exists, it is maintained quietly, without the dramatic energy seen on Europa. It is another example of gravity providing just enough influence to sustain, without overwhelming. Together, Ganymede and Callisto illustrate an important truth about Jupiter's mass. Gravity does not produce a single outcome. It creates a range of possibilities. Close in, it generates heat and motion. Farther out, it allows calm and preservation. This gradient of influence is one of Jupiter's defining characteristics. The planet's mass is so great that it creates an entire spectrum of environments around it, each shaped by distance and balance. Worlds close to Jupiter burn, worlds slightly farther hide oceans, and worlds farther still remain unchanged for billions of years. And yet, all of them remain bound. As you imagine Ganymede and Callisto moving through space, picture their slow, steady orbits. Days passing, years passing, millions of years slipping by without urgency. Jupiter remains at the center, massive and constant, while these moons trace their paths with quiet precision. There is something deeply calming about this arrangement. Stability created not by stillness, but by motion that repeats reliably over immense spans of time. A reminder that not all change needs to be fast or dramatic to be meaningful. Jupiter's mass makes this possible. It anchors these moons in place, protects them from chaos, and allows each to follow its own evolutionary path. In doing so, it demonstrates how gravity can be both creative and conservative, in shaping some worlds while leaving others nearly untouched. Jupiter as a cosmic shield, Far beyond its clouds and moons, Jupiter's mass continues to shape events on a much larger scale. Its influence does not end at the edge of its magnetosphere or the outermost orbit of its distant moons. Instead, it reaches outward into the broader solar system, quietly altering the paths of wandering objects long before they come close to the inner worlds. This role is often described as Jupiter acting as a shield, not a barrier in the physical sense, but a gravitational presence so strong that it changes trajectories, redirects motion, and reshapes the long-term flow of debris through the solar system. Over billions of years, this influence has helped determine how often comets and asteroids reach the region where Earth and the other inner planets reside. In the early solar system, debris was abundant. Leftover material from planet formation drifted through space in vast numbers. Some of it settled into stable orbits. Much of it did not. Objects collided, fragmented, and wandered unpredictably, guided by gravity alone. Jupiter, already massive at this early stage, became one of the dominant forces shaping this chaos. Its gravity pulled strongly on nearby debris, capturing some objects into orbit, scattering others outward, and redirecting many away from the inner solar system. This process did not happen all at once. It unfolded slowly over immense spans of time as Jupiter continued to sweep through its orbit again and again. Some comets that approach the Sun today have had their paths altered by Jupiter many times in the past. They may have originated far beyond the outer planets, only to be pulled inward by the Sun's gravity. When they encounter Jupiter, their orbits can change dramatically. Some are flung back into deep space, others are redirected into shorter orbits. A few are captured entirely, becoming long-term residents of Jupiter's domain. Asteroids feel this influence as well. The asteroid belt between Mars and Jupiter bears clear evidence of Jupiter's gravitational presence. Gaps within the belt, known as resonances, mark regions where repeated gravitational nudges from Jupiter have cleared material away. These gaps are silent records of Jupiter's mass shaping space over millions of years. Occasionally, Jupiter's role as a shield becomes visible in a dramatic way. In 1994, fragments of a comet known as Shoemaker-Levy 9 collided with Jupiter's atmosphere. One by one, these fragments plunged into the planet, releasing enormous amounts of energy high above the clouds. For weeks, dark scars marked the impact sites, visible even from Earth. It was a rare opportunity to witness Jupiter's role directly, absorbing impacts that might otherwise have reached the inner solar system. But most of Jupiter's shielding work is quiet, unseen, gradual. Gravity does not hurry. It alters motion patiently, orbit by orbit, encounter by encounter. Jupiter's mass gives it the ability to influence objects long before they pose a threat to smaller worlds. This shielding effect is complex. In some cases, Jupiter can redirect objects toward the inner solar system rather than away from it. Gravity does not choose outcomes with intent. It follows physics. Yet over long periods, the net effect of Jupiter's presence appears to reduce the frequency of large impacts on Earth. This influence may have played a role in Earth's long-term habitability. Fewer catastrophic impacts mean greater stability. Greater stability allows lifetime to develop, diversify, and persist. In this indirect way, Jupiter's mass may have contributed to the conditions that allowed life to flourish here. Jupiter did not protect Earth deliberately. It simply existed. Its mass shaped the environment, and the environment responded. As you consider this role, it is important to remember that Jupiter's influence operates on timescales far beyond human experience. A single deflection may take thousands of years to matter. A change in orbital patterns may unfold over millions of years. The solar system responds slowly, adjusting to the presence of its giant member. there is something reassuring in this slowness. Jupiter's mass acts not through sudden intervention, but through constant presence. It does not need to react quickly because it never stops exerting influence. As you imagine comets drifting through space, picture Jupiter ahead of them, massive and silent. Some objects pass by unchanged, others feel their paths bend slightly. Over time, these small changes accumulate, reshaping the flow of material through the solar system. Jupiter's role in shaping the early solar system. Long before Earth had oceans, long before the moon settled into its familiar orbit, in the solar system was a very different place. It was not calm or orderly. It was a swirling disk of gas, dust, and ice surrounding a young sun that had only recently begun to shine. In this early environment, Jupiter's mass began to assert itself. The material that would become the planets had not yet settled into stable paths. Particles collided gently, stuck together, and slowly grew. Over time, some of these growing bodies became large enough for gravity to accelerate the process, pulling in more material and growing faster still. Jupiter was one of the first to reach this threshold. Forming beyond the region where ice could survive, Jupiter had access to vast amounts of material. Ice, gas, and dust were abundant. As Jupiter's core grew, its gravity strengthened, allowing it to pull in enormous quantities of hydrogen and helium from the surrounding disk. This rapid growth set Jupiter apart from the smaller worlds closer to the Sun. As Jupiter gained mass, it began to reshape the environment around it. Its gravity carved gaps in the disk of material, altering the flow of gas and dust. Regions that might have formed additional planets were disrupted. Material was scattered inward and outward, changing where and how other worlds could grow. The asteroid belt is one lasting result of this process. Instead of forming a planet, the material in this region remained fragmented, its growth repeatedly interrupted by Jupiter's gravitational influence. What remains today is a sparse collection of objects, each following a path shaped long ago by the presence of a giant nearby. Jupiter's mass also influenced the formation of Saturn and the other outer planets. By altering the distribution of gas in the disk, Jupiter affected how much material remained available farther out. In some models, Jupiter's early migration through the disk helped shape the spacing and sizes of the planets that followed. These migrations were slow, unfolding over hundreds of thousands or even millions of years. Jupiter did not race through the solar system. It drifted, guided by interactions with the surrounding disk. As it moved, it carried its gravitational influence with it, reshaping the architecture of the system. Closer to the Sun, the inner planets were also affected. Material scattered inward by Jupiter's growth may have delivered water and other volatile compounds to Earth and its neighbors. In this way, Jupiter's mass may have indirectly contributed to the ingredients necessary for life. The early solar system was a place of balance and tension. Gravity pulled material together, while motion and collisions prevented immediate collapse. Jupiter's mass tipped this balance in subtle but lasting ways, guiding the system toward the configuration we see today. Once the disk of gas dispersed, Jupiter's position stabilized. Its mass, now fully established, became a constant presence. The chaotic era of formation gave way to long-term stability, with planets following predictable paths shaped by their early interactions. This transition from chaos to order is one of Jupiter's most significant contributions. By gathering so much mass so early, Jupiter helped define the solar system structure. He's setting the stage for billions of years of relative calm. As you imagine this distant past, picture a glowing sun surrounded by swirling material. Within that disk, a giant planet grows steadily, its gravity quietly reorganizing everything nearby. There is no sound, no sudden movement, only slow change unfolding over vast spans of time. What we learned about Jupiter's mass understanding. Jupiter's mass is not a single discovery. It is a process. Each mission, each measurement, each subtle observation has added another layer to a picture that remains incomplete. Jupiter does not reveal its weight all at once. Its mass expresses itself indirectly through gravity, motion, and long-term effects that unfold slowly over time. For centuries, astronomers could only infer Jupiter's mass by watching how it influenced other objects. Moons orbiting the planet moved faster than expected. Their paths curved sharply, bound tightly by an unseen force. Even without knowing the details, it was clear that Jupiter was extraordinarily heavy. When Newton described gravity mathematically, Jupiter became one of the first testing grounds for these ideas. The motion of its moons matched predictions precisely, confirming that Jupiter's mass could be calculated by observing how strongly it pulled on its companions. From these early calculations, Jupiter emerged as the dominant planetary mass in the solar system. But knowing how heavy Jupiter is does not immediately explain how that mass is arranged. For a long time, scientists imagined Jupiter as having a dense, solid core surrounded by layers of gas. This idea was borrowed from Earth-like intuition. Solid center, lighter material above. Orderly layers stacked neatly by weight. As measurements improved, this picture began to soften. Data from spacecraft revealed subtle variations in Jupiter's gravitational field. These variations indicated that mass inside the planet was not distributed evenly. Some regions pulled more strongly than others. Gravity did not behave as it would if Jupiter were a simple, layered object. These small deviations mattered. They suggested motion beneath the clouds. Flow, mixing. A planet that was not static inside, but alive with slow internal circulation. The Galileo spacecraft provided some of the first clues. By tracking its orbit carefully, scientists observed how Jupiter's gravity affected its path. Tiny accelerations and decelerations revealed that Jupiter's interior was more complex than expected. Later, Juno refined these measurements dramatically. Juno's orbit was designed to skim close to Jupiter's cloud tops, passing through regions where gravitational differences could be detected with extreme precision. As Juno flew past, its radio signals shifted slightly due to changes in velocity caused by Jupiter's uneven gravitational pull. From these shifts, scientists constructed detailed maps of Jupiter's gravity field. What they found challenged long-held assumptions. Instead of a compact, sharply defined core, Jupiter appears to have a fuzzy core. Heavy elements are spread out over a large region rather than concentrated in a single solid center. The boundary between core and surrounding layers is gradual, blurred by mixing and motion. And this suggests that Jupiter's immense mass caused its interior to churn and blend over billions of years. Gravity compressed material inward, while heat and rotation stirred it continuously. Over time, distinct layers softened into gradients. This blending tells a story about Jupiter's formation. Rather than forming slowly and neatly, Jupiter likely experienced a turbulent early history. As it gathered mass rapidly, impacts with large bodies may have disrupted any early core, spreading heavy elements outward. Jupiter's gravity then locked this mixed structure in place. Even today, Jupiter's mass continues to shape its interior. The planet is not frozen in time. It slowly contracts, releasing heat. Its internal flows persist, driven by pressure and rotation rather than surface conditions. Another key discovery concerns how deeply Jupiter's atmospheric winds extend. Before Juno, scientists assumed that the colorful bands and jet streams visible on Jupiter were shallow features, confined to the upper atmosphere. but gravity measurements revealed that these winds reach far deeper than expected, penetrating thousands of kilometers below the cloud tops. This means that Jupiter's mass and motion are linked far beneath what can be seen. The atmosphere is not a thin skin. It is a deep, moving layer that interacts with the planet's interior. The deeper these winds go, the more mass they involve. Moving mass alters gravity. By measuring these changes, scientists can trace the depth and strength of Jupiter's atmospheric circulation. This discovery reinforced a central theme. Jupiter is not layered simply. It is a planet of gradients and flows, shaped by mass that never truly settles. Jupiter's mass also explains why its size has remained stable for so long. Despite ongoing contraction, Jupiter does not shrink rapidly. The balance between gravitational compression and internal pressure maintains its overall size. Add more mass, and Jupiter would compress further rather than expand. Remove mass, and it would relax slightly outward. This balance places Jupiter near a natural limit for planetary size. Even planets far more massive than Jupiter, known as superjupiters, can be similar in size due to extreme compression. Jupiter represents a turning point, where adding mass no longer makes a planet much larger, only denser. In this sense, Jupiter's mass defines a category. It marks the boundary between planets and stars. Just beyond Jupiter's mass, objects begin to ignite nuclear reactions. Jupiter came close, but never crossed that line. Its mass was enough to dominate the solar system, but not enough to shine. This near miss is part of what makes Jupiter so fascinating. It is a reminder that cosmic outcomes depend on delicate balances. Slight differences in mass lead to entirely different fates. As measurements improve, scientists continue refining Jupiter's mass distribution. Each pass of Juno adds data. Each analysis deepens understanding. And yet, many questions remain unanswered. How exactly did Jupiter's core form? How much heavy material does it contain? How stable is its internal structure over billions of years? These questions persist because Jupiter resists simplicity. Its mass creates complexity. Its gravity smooths some features while amplifying others. It is not a planet that reveals itself easily. And perhaps that is fitting. Jupiter has always been a world that demands patience. Its influence unfolds slowly. Its interior hides beneath immense pressure. Its mass cannot be grasped fully through a single measurement or model. As you reflect on what has been learned, notice how often gravity appears as the guiding thread. Everything comes back to mass. The storms, the moons, the magnetic field, the stability, the uncertainty. Jupiter's mass is not just a number. It is a presence, a constant shaping force that has defined the solar system from its earliest moments and continues to do so today. Jupiter compared to other giants. To truly understand how massive Jupiter is, it helps to step back even farther. Beyond the boundaries of our own solar system, beyond familiar orbits and known worlds, there exists a vast population of giant planets. Some resemble Jupiter closely. Others push the limits of what we consider a planet at all. In this broader context, Jupiter becomes both extraordinary and representative. It is massive, but not unique. Powerful, but not the largest possible. Its true significance emerges not from being the biggest thing in existence, but from where it sits on a spectrum of giant worlds. Within our own solar system, Jupiter stands at the top. Saturn, the second largest planet, is impressive in size, but far lighter by comparison. Though Saturn's diameter is only modestly smaller than Jupiter's, its mass is less than 1/3 as much. This difference reveals an important truth. Size alone does not define mass. Our Saturn is puffier, less compressed, its material spread more loosely under weaker gravity. Jupiter's greater mass compresses its interior far more tightly. The difference can be felt in gravity, density, and internal pressure. Where Saturn's atmosphere transitions more gently inward, Jupiter's gravity presses harder, shaping deeper layers more intensely. Uranus and Neptune, often called ice giants, are different still. Though large compared to Earth, they are small compared to Jupiter. Their masses are only a fraction of Jupiter's, and their compositions include far more heavy elements like water, methane, and ammonia. These planets formed under different conditions, with less access to hydrogen and helium. Their gravity is strong enough to hold atmospheres, but not strong enough to gather the enormous gas envelopes Jupiter possesses. They illustrate how sensitive planetary outcomes are to mass and timing. Jupiter, by contrast, formed early and grew fast. Beyond our solar system, astronomers have discovered thousands of giant planets orbiting other stars. Many of these are called gas giants, and some are even more massive than Jupiter. These worlds offer valuable perspective on what Jupiter is and what it is not. Some exoplanets, known as hot Jupiters, are similar in mass to Jupiter, but orbit extremely close to their stars. Their proximity exposes them to intense radiation, inflating their atmospheres and altering their structure. Despite having Jupiter-like mass, they behave very differently. Others are super Jupiters, planets several times more massive than Jupiter. At first glance, one might expect these worlds to be much larger, but often they are not. Or as mass increases beyond Jupiter's level, gravity compresses the planet more strongly, counteracting expansion. This compression leads to a surprising result. A planet twice as massive as Jupiter may be only slightly larger or even smaller in radius. Beyond a certain point, adding mass makes planets denser rather than wider. Jupiter sits near this turning point. It is massive enough to compress hydrogen into metallic states, but not massive enough to ignite nuclear fusion. Just beyond Jupiter's mass range lie objects known as brown dwarfs, bodies that blur the line between planets and stars. Brown dwarfs are heavier than Jupiter, sometimes dozens of times more massive. Their gravity compresses their interiors so intensely that a brief fusion of certain elements can occur. They glow faintly, not like stars, but not like planets either. A Jupiter did not cross this threshold. Had Jupiter been even a few times more massive, it might have become a brown dwarf, emitting light of its own, transforming the solar system into a binary system with two shining bodies. Earth's history would have been profoundly different. Instead, Jupiter remained just below that line. This near miss is part of Jupiter's significance. It represents a balance point in planetary formation, massive enough to dominate, light enough to remain dark. Among the giants, Jupiter occupies a kind of reference position. When astronomers compare other giant planets, Jupiter often serves as the standard. Masses are measured in Jupiter masses. Radii are compared to Jupiter's radius. It has become the unit by which giants are understood. Yet Jupiter is not average in the universe. Many planetary systems contain giants far closer to their stars than Jupiter ever was. Some lack giant planets entirely. Others contain multiple massive worlds interacting in complex ways. What makes Jupiter special is not just its mass, but its placement. It orbits far enough from the Sun to remain cool, stable, and long-lived. Its distance allows it to retain its atmosphere without extreme heating. Its position allows it to shape the solar system without disrupting it. In this sense, Jupiter's mass is perfectly tuned to its environment. Comparing Jupiter to giants elsewhere also highlights how mass influences planetary behavior. More massive giants have stronger gravity, more intense magnetic fields, and deeper internal pressures. Less massive ones lose gas more easily and evolve differently over time. Jupiter's mass places it in a stable middle ground. It retains its atmosphere. It sustains internal heat. It maintains powerful storms and magnetic fields. Yet, it does not burn, collapse, or fade quickly. This stability over billions of years is rare and valuable. As you imagine Jupiter alongside other giants, picture a range of worlds scattered across the galaxy. Some closer to their stars, glowing softly from heat. Others drifting far out, cold and distant. Some heavier, some lighter. Among them, Jupiter remains distinctive not because it is the largest, but because it is balanced. Its mass defines a threshold where planets become something more than Earth-like worlds, yet something less than stars. It marks a transition point in cosmic structure. This is why Jupiter continues to matter far beyond our solar system. Understanding its mass helps scientists understand how planets form everywhere. It provides a benchmark against which countless other worlds are measured. Living beside a giant Jupiter has always been there. Long before humans learned to count time. Long before the first ocean settled on Earth. Long before the sun itself had fully stabilized. Through all of that time, Jupiter has remained a constant presence in the solar system. Massive, silent, turning slowly in the darkness, shaping the paths of worlds without ever needing to announce itself. To live in a solar system with Jupiter is to live in a system defined by weight. Every planet, every asteroid, every wandering comet exists within an architecture shaped by Jupiter's mass. Its gravity does not dominate loudly. It does not overwhelm constantly. Instead, it sets the tone. A deep, steady influence that guides motion over millions and billions of years. From Earth, Jupiter appears small, a bright point of light, easy to miss among the stars. And yet, that point of light represents more mass than all other planets combined. A reminder that appearance rarely reflects influence. Jupiter teaches us that the most powerful forces are often the least dramatic. Earth's history unfolded under Jupiter's watch. As continents drifted and climates changed, Jupiter continued its slow orbit. As life emerged, evolved, and diversified, Jupiter's gravity quietly shaped the solar system's stability. The paths of comets were bent. The rhythm of impacts was altered. The inner planets were allowed long periods of calm. None of this happened with intention. It happened because Jupiter existed. This is one of the most profound lessons Jupiter offers. The universe does not require design to create structure. It requires only mass, gravity, and time. Given enough of each, order emerges naturally. Jupiter embodies this principle perfectly. It is not a world of surfaces and landscapes, but of pressure and flow. It does not host cities or oceans of light, but oceans of hydrogen compressed into unfamiliar states. Its storms are not fleeting weather events, but long-lived expressions of internal heat and rotation. And yet, despite all of this alien nature, Jupiter feels familiar in one important way. It is predictable. Its orbit does not wander. Its gravity does not fluctuate wildly. Its influence remains steady. There is comfort in that steadiness. When we imagine the future of the solar system, Jupiter remains a central figure. Long after the sun begins to change, long after Earth's surface transforms beyond recognition, Jupiter will still be there, holding its mass together, turning slowly in space. Even as the sun eventually grows brighter and then older, Jupiter's fate will unfold gradually. Its atmosphere may change, its moons may evolve, but its immense weight will continue to shape outcomes long into the future. Jupiter does not rush toward its destiny. It waits. In many ways, Jupiter represents time itself. Not the time measured by clocks or calendars, but geological time, cosmic time, time measured in orbits and eras rather than moments. Thinking about Jupiter shifts perspective. It reminds us how brief human lives are, not in a discouraging way, but in a grounding one. Our moments exist within something far larger and more patient than ourselves. There is no need to hurry when the universe moves this slowly. As you lie listening, consider how Jupiter's mass bends not only space, but thought. It invites stillness, reflection, a sense of place within a vast system that continues whether or not it is observed. Jupiter does not require belief or attention. It exists regardless. And yet, when we choose to look up, when we choose to learn, Jupiter offers something quietly reassuring. Proof that stability can arise from immensity, that power does not need chaos, that mass can create balance rather than destruction. Living beside a giant means living with an influence we rarely notice. The tides of space move slowly. The forces at work are gentle but persistent. Change happens, and still, but on timescales that allow complexity to flourish. Jupiter's mass has been shaping this solar system since its earliest days, and it will continue to do so long after human voices fall silent. In that sense, Jupiter is both ancient and enduring, a reminder that the universe is patient. As this journey comes to rest, there is nothing left to understand, no final fact to remember, only an image to carry with you. A giant planet, wrapped in clouds, turning slowly in the dark. Its gravity stretches outward, invisible but constant. Its presence felt even across vast distances, holding moons, shaping paths, defining the structure of everything around it. And somewhere within that system, a small, quiet world continues to turn beneath its own thin sky. If your thoughts begin to drift now, let them drift without resistance. Jupiter will remain where it is, massive and steady whether watched or not. There is no ending here, only continuation, rest,